Alright, my name is Chan. I'm from Cisco Networking Academy. So today we're going to talk about address resolution protocol. It's a very important concept in IP. So the lecture outline is we're going to talk about ARP. Why do you need ARP? Then Arping between subnet and inter-subnet communication. Alright, suppose you have this scenario. Alright, you have this PC with this IP address 1111, this PC with this IP address 1.1.2, and the MAC address is AAAA and BBBB. Let's say from this PC you want to ping this PC. What would you see in the network analyzer? What would you see? What will be the source MAC address? What will it be? AAA lah. Alright. Destination MAC address? Source IP? Correct? Correct? Wrong. Alright? This is wrong. Okay, this is what you think you're going to get. Alright? But first, this PC, how does he know that this 1.1.2 MAC address? How do you know? How would you know? Let's say when you ping your neighbor, what's your IP address? Then you just ping the IP address in. Did he tell you the MAC address? Then how will you know to put it in the packet? Let's say this PC, Ali, and this Achong. You tell Ali, say, Achong, what's your IP address? 1.1.1.2. Then Ali will key in 1.1 ping 1.1.1.2. Did Ali key in the MAC address? Then how do they know? Then without the MAC address, how does he going to find out? How it's going to ping? So there's something is missing, correct? The missing part is there must be a way or protocol to resolve the MAC address to IP address mapping, correct? So after the mapping is resolved, then only the IPv4 communication begins. Alright? So this is address resolution protocol. That means you have two addresses, you want to resolve the mapping. That's why they call it a address resolution protocol. So first, when you ping AA, it will send a broadcast. That means send to everybody with this IP address and say, who is 1.1.2, please tell 1.1.1 at this MAC address. Alright? Then BB will reply to AA and say that 1.1.2 at BBB MAC address. Okay? Then only the ping can begin. Alright? Before any IP communication, you must have address resolution. Okay? IPv4. IPv6 will be slightly different. Okay? But I think we might not cover lah for your case. We might not cover it. We'll make some other video. Alright? You can pay us a visit. Alright? Or in YouTube. Alright, so what happened? Let's say when you type in your PC ARP -A, you can see this is the IP address, this is the MAC address. So when you ping this IP address, you get a reply. Then you can see the IP address and the MAC address. Alright, it's maintained locally in this PC. Alright. Okay, so if you can see, this is an actual packet trace. This is the ARP request. So you can see it's broadcast. Then 8086 is the ARP packet. Alright. Then this is the ARP reply. Then this is the ping packet. This is the ping reply. Okay. This is the source MAC address, destination MAC address, the IP header 80800 version 4, header length is 5, and so on. Then the IP address will be 10 100 26 252, 10 100 26 I think this is 234, this is 252. Alright, you can decode it. Okay, so the ARP request, you send the request is a broadcast to everybody. Then the system B will reply back to system A with the MAC address. Okay, so once you know the physical address, you can do the ping. Okay, alright. So request is broadcast, reply is unicast. So this is the packet format. You don't have to remember this. Definitely it should not come out in the exam. Alright, we will not test you for memory. So this example, this is a ARP request, then this is the ARP reply. Okay, this is in the packet format. In the actual packet trace, it looks like this. Okay, it looks like this in the actual packet trace. Okay, there is a 4 scenario. One is within the same network. One is between the PC and the router. Another one is router to router. Another one is router to PC. Okay. All right. So I'm not sure whether you know anything about netmask. Do you know anything about netmask? No, huh? Don't worry, I'll teach you the netmask later on. Alright, so first thing is you have, let's say you have 1.1.1 want to ping 1.1.2. Alright, so what happened is that it's like this. Okay, let me resize. Okay, okay, so you have 1.1.1.1, alright, and this is your net mask. Alright, so you will take the IP address and you end it with the net mask. One is, this is 1, correct? And this is 255, correct? When you add it, what do you get? Huh? What do you get when you add it? You get 1, correct? 1 and 1, you get 1, correct? So this one you get 1.1.1.1.0. Okay? This is your network. Okay? Alright? So you have 1.1.1.2 and you end it with 255. What do you get? 1110, isn't it? So these two is the same, isn't it? Okay? That means it's the same network. They are talking in the same network. Okay? So let's resize it back. Alright, let's go to PowerPoint. So when they see the source and the destination is the same network. So what they do, they just find the MAC address. Do you have 1.1.2 MAC address? If you have, you just send. If you don't have, then you send a ARP request directly. Okay? Let's say it's in a different network. You can see this one want to ping this one. Okay? So they are different. Correct? You see they are different network. Then you need to send the packet to the default gateway, which is here. That's your default gateway, 1.1.2.254. Okay? That's the default gateway. Okay, default gateway. So if your destination network is not equals to your source, forward the packet to your default gateway. So what is your default gateway MAC address? You don't know. So you send a up reply. Okay, you send a up request to your default gateway. Okay, then what will happen when the packet reaches the other end? Okay, let's see. So this is direct delivery, this is indirect delivery. Alright, this is indirect delivery, this is direct delivery. Okay, so let's say you put a sniffer here and you put a sniffer here, and you want to ping from this one 1.1.1 to 1.1.3.2 in a different network. Okay, so you're going to ping assuming that all your caches are empty, up cache is empty. So what you're going to see on this network, what you're going to see, you're going to see if 1.1.1 does not have an entry to here, 1.1.254, it will send an up request who is 1.1.254, the default gateway, tell 1.1.1 at AA1. Alright, then you send a ping packet with a MAC address. So this is what you're going to see in this network. First, you're going to send a up request to resolve the default gateway MAC address. Okay, after the default gateway MAC address is resolved, then you got the default gateway MAC address already, then you will send with the R1. You can see here is R1. You're using the default gateway MAC address. You're not using this MAC address. You're using the default gateway MAC address. Okay, then you send, and this one get forwarded to here. Okay, there's also the definition called proxy up. A proxy up is that it used to create a subnetting effect. The proxy up is an up that acts on behalf of a set of hosts. When the router runs a proxy up, receive an up request looking for the IP address of one of these hosts, the router will send an up reply announcing its own addressing. After the router receives the actual packet, it sends the packet to appropriate host. So let's say you request for, let's say a destination request for this IP address, alright, 56 and so on. This in another network. When this host send a request to this router will reply on behalf of this PC. Okay, so let's go back to here. So this packet finally reaches here. Okay, so then router 2, once it reaches here, it doesn't know 1.1.3.1 MAC address. The packet reaches here, but it don't know the MAC address for 1.3.1. So what to do? You need to send out a up request for 1.1.3.1 before it can send out the ping packet, because the packet reaches here, it cannot ping this one because it don't have the MAC address. So what should the router do while the packet is still here? They just, if it's a lazy and cheap implementation, just drop the packet lah. Just drop the packet, send out an up request, clean. Then the sender will retransmit, isn't it? So when the next up packet, when the next ping packet came, the up entry is already there. Then it can okay. So if it's a good implementation, you should buffer the packet and then send the packet after receiving the up response. Okay, but sometimes how do you buffer if it's 10 gigabit or 1 gigabit? It's difficult. So this is what you're going to see in sniffer 2. You can see R2 will broadcast to get 1.1.3.1 MAC address. Okay, once they get the MAC address, then the ping packet will go through. Alright, the ping packet will go through here, and then you generate a ping response. So you can see here the MAC address is R2. Alright, the MAC address here is R2. Okay, so if you can see the communication for at layer 2 is this one talking to this one, this one talking to this one, this one talking to this one. So you can see over here is AA1 talk to R1, and this one R2 talk to BB1. Alright, then from N to N is 1.1.1 talks to 1.3.1. Okay, so N to N communication using IP is N to N. The IP address does not change, whereas the MAC address will change every network. In every network it will change. Okay, so that's why they say layer 2 is point to point, layer 3 is end to end. Okay, so by now you should know how does the ARP work. Okay, and for the rest, RAP, DCP, BootP, that one is you can do your own self-study. Alright, if any question you can email us. The slides will be available in our website. Thank you.